Hello guys, welcome back to TechDose, and in this video we will look at maximum number of events that can be attended to problem, which is from LeetCode number 1751. In this problem you are given an array events I where events I denotes three values: the start and end day of the event as well as the value that is associated by attending the event, which means the profit that you can make. The ith event starts at start day at I and ends at end day at I, and if you attend this event you will receive a value I. You are also given an integer k which represents the maximum number of events that you can attend, and you can only attend one event at a time. If you choose to attend an event, you must attend the entire event. And note that the end day is inclusive. That is, you cannot attend two events where one of them starts and the other one ends on the same day. So if I say that there is an event which starts with 1 and then it ends at 2, and there is another event which starts at 2 and then it ends at 4, then you can attend only one of the event. You cannot attend them both because these 2 and 2 are actually overlapping. So this is inclusive range, and that is why they are overlapping. In this problem we are asked to return the maximum sum of values that you can receive by attending the events. And if you look at example number 1, then we have 3 events which are given. The diagram is also mentioned. The first event goes from 1 to 2, that means it covers the slot number 1 and 2. Second event covers the slot 3 and 4, and the third event covers the slot 2 and 3. Since k value is 2, we cannot attend more than 2 events, and according to the constraint that a single person will be attending the event, therefore no 2 parallel events can be attended. Okay, the events attended must be non-overlapping. So if the person happens to attend the first event, then he can surely not attend event 2 if he attends event number 0, because they are overlapping. And so the person can attend event 0, event 1, that is one way of assignment, or the person can attend only event 2 and skip both event 0 and event 1 because they are overlapping, right? So how many ways are there for a person to attend the event? So if you have, let's say, event 0, event 1 and event 2, then each event has 2 choices in the worst case. That means a person can either skip that event or attend it. Skip that event, attend, or skip that event or attend. So since each event will have 2 options in the worst case, so the number of combinations are going to be 2 to the power of number of events. Let's say number of events are n. So you can create 2 to the power n number of sequences, and within that you have to follow the constraint that you cannot cover more than k events. Then one of the sequence will give you the maximum profit or maximum value that you can get, which we needed to return as our answer, right? So I hope this is clear. In this particular problem, if you attend event 0 and event 1, you get the max profit, which is 4 plus 3, right? 4 plus 3, which is 7. So this problem should be clear, and in this case the constraints given are k to be less than equals to event length. That means the number of events that you can attend is always less than equals to the number of events that are present. K times events dot length is less than equals to 10 to the power of 6. This is the most important constraint because this denotes that if n is the number of events and k is the number of events that a person is allowed to attend at maximum, then if you write an order of nk algorithm, then that is going to be maximum 10 to the power 6 in case of runtime computations, and you know that 10 to the power 8 is a standard for 1 second. Therefore 10 to the power 6 computations for nk will definitely pass. Okay, otherwise if the events dot length was somehow 10 to the power of 4 and k would also be 10 to the power 4, then it can reach to 10 to the power 8 where it would have given you TLE. Okay, so in this case this constraint is the most important, just to justify that order of nk solution will easily pass. The start day at I is always less than equals to end day at I, and the maximum value is 10 to the power 9. So everything falls within the 32-bit integer. Each of the value I is less than equals to 10 to the power of 6. Now I hope the problem statement is clear. Let's look at some observations. In this case, as I explained, each of the event have 2 choices, whether the event can be skipped by the person or it can be attended. So if you skip the event, then you go from the ith event to the I plus 1th event without considering the fact whether they are overlapping or not. Because if you are already at the ith event, and if you are considering to include or exclude, then that means the previously included event must have been to the left hand side to the start of the ith event, isn't it? Otherwise, if the previously included event was somehow overlapping, then for the ith event you will only have exactly one choice. That means you have to exclude the ith event, you cannot include it. Okay, so in this particular case, if you are trying to exclude an event, that means skip the event, it is always possible whether the previously included event was overlapping or not overlapping, you can always exclude. So if you exclude ith event, you have to go to the next event, which is event at I plus 1, without thinking about if I plus 1 is overlapping with I, because I was not included, right? The other option is the ith event will be included. So if the ith event will be included, you have to see the end of the ith event and you have to select the next event which is earliest in terms of start time, and which exceeds the end event I. Okay, so since the values are inclusive, therefore I am searching for end event I plus 1th value, something which is greater than equals to this time. Okay, and it should be as left as possible in the event. So you have two options. Let's say this is event I plus x and let's say this is event I plus x plus 1. So if you have these two options, definitely event I plus x is to the left hand side and greater than event I, which is on the timeline. So I will be going with this particular event, right? All the rest of the events, all these three events will be skipped, because even if you go through them, you cannot include them, you have to exclude them, right? So what's the point of going through them? So if you have included event at I, then we are looking for such event at I plus x, which is greater than the end point of the event I, which is ei, greater than ei, right? So you can say that greater than equals to ei plus 1, because floating numbers are not present here. And the event must be as left as possible, which is greater than equals to ei plus 1, because if it is not as left as possible and if you are going here, then maybe possibly including the previous event would have made you more profit, isn't it? So you can think that ordering of the events would be required. Okay, ordering of the events based on the start time will be required so that you can follow this kind of selection process. That means you can follow a timeline moving from left to right. So we will be ordering the events to solve the problem from left to right. If you want to maximize the profit, then for these two selections you will get two different answers. For skipping the event you will get certain profit, and for attending the event you will be getting a certain profit. And to this profit, since you have attended the ith event, you will also be adding the profit, that means the value that you get for attending the ith event. Since you did not attend the ith event for skip event case, therefore we are not adding anything here. Since we want to maximize the sum or maximize the profit, that is why we will be using the max function. Okay, so I hope this entire thing is clear. Now even the observations are clear, you can think that we can solve by all possibilities using recursion. So let me tell you that if the set of events are given, in this case 3 events, the first thing that I will be doing is sorting based on the start point. If 2 start points are same, then it will be sorted based on the end point in ascending order. Okay, so let's say that I have sorted it. After sorting, I will assume the indices to be the even number, and let's try to solve it by using recursion all possibilities. Now the k value is 2, that means we cannot attend more than 2 events. So if I move from left to right, then initially I will be at event number 0, and at event number 0 I have two choices, whether I can choose to not include this event or include this event. Now here the k value was equals to 2, right? K value was equals to 2. Now the profit you can say will be equals to, it will be unknown, it will be the maximum of the skip event case and the include event case. If you skip it, then you go to event number 1, and again you will have two choices of excluding the event or including the event. Again the k value will be 2 because you did not include the 0th event, right? And again you have to calculate the profit here. The profit is unknown right now. Now if you exclude the first event, you will be going to the second event, and again here you will be facing two choices whether to exclude or include it, and the k value being 2 because 0th and the first event are not included, so the profit is still unknown. Now let's follow the path and try to calculate it. So if you follow the path from 0, not including 0, not including 1 and not including 2, then you will be going out of bound, which means that your position pointer will be going out of bound. It will be equals to n here. N is equals to 3, which is the count of events, and that is why the profit returned will be 0 from this case. Okay, so from the exclude case you got a profit of 0. Now if you try to include the second event, then what you have to do is you have to add a value 3 because you are trying to include the second event, and then you go out of bound. The out of bound will return 0, but the 0 will be added to 3 and the include case is giving you 3. So take the max of this 0, 3, it will be 3. So you will be returning a value 3 from the sub problem number 2 here. Okay. Now when you go to this index 1 again, then you have tried not to include it. Can you include this event? Yes. And if you do that, then you will go to event number 2. What is the k value? K value becomes 1 because you have included the first event, and the index from which you can start taking the index will be equals to whatever is the end index at 1, which is 3 plus 1, that means 4. So if you are solving for this 2 now, it should have a start value starting from at least 4. A value should be greater than equals to 4, but here the value is 3. That means 2 cannot be included, it has to be excluded. And if you exclude 2, then you will go out of bound, and so it will be returning 0. So there is only one option at 2, since the start value here 3 was less than the given new start point, which was 4, right? So this will be returning a value 0 as well, right? So when this event number 1 was included, then how much profit could be made? The profit would be 8 plus 0, and if it was excluded, the profit would be 3. So what is the max of 8 plus 0, 3? It will be 8. So the profit 8 will be returned from this one, right? Now on the other side, if you see, can you include this 0th event? Yes, you can include it. So if you include it, the k value will become 1. That means you have included an event, right? And if you do that, then the new start point should be minimum 2 plus 1, which will be 3, which must be to the right of the previously included event. Now what is the start point of this index 1? It is 2, which is less than 3. So there is only one option here to exclude. You cannot include this event 1, otherwise it will be overlapping. So you will be going to 2. Okay, and here the k value will be 1, right? So at this point you see that the end point must be greater than equals to 3, and it is 3. So yes, there will be two options at 2. You can either exclude it and include it. If the k value would have been 0, then definitely I cannot include this second event as well, right? So the k value is greater than 0 in all these cases, so there was no problem. Now if you exclude this second event, then you will be reaching to the end, and this will be returning a profit 0 because this is out of bound case. Now if you try to include the second event, then the profit to be made is 3. So 3 plus return value will be 0 from out of bound, and so the max profit of 3 plus 0, 0 will be 3. So this will be returning a value 3. Okay, so this will also be returning value 3. Now if you had included the 0th event, the profit would have been 4 plus the return value being 3, which is 7. And if you had excluded the 0th event, the profit would have been 8. So the max profit is 8, and that is why this will return a value 8. So using this recursion tree diagram, you can make out that the maximum profit is going to be 8, and we have tried all the possibilities, isn't it? Now if you have followed this recursion tree diagram, then the number of nodes in the worst case are going to be 2 to the power of n, and so you can assume that the time complexity will also be around 2 to the power of m, and the space complexity will be the depth of the recursion tree diagram, which is not more than order of n. So this is the time and the space complexity using recursion. But if you look at the recursion tree diagram nodes, then it is denoting about what is the event number, or you can say the event index, and the k value. So these are the two variables which defines your result. If you write the recursion code, then you will see that event number and the k are the two variables on which your answer depends, because event number tells you about which event number you are looking and how many events are left to the right hand side, and the k value tells you about how many events needs to be included. Both these are important because maybe you are at event number 1 and the k value is 0. That means you cannot include anything now, so the profit has to be 0. Versus if your k value was 1, then you can include at least one event, so the profit will be different. So profit will be varying for different k values, and also the profit will be varying for the same k value but different event number. Okay, so these are the two variables on which your answer depends, and you can call them as DP states. Why these are called DP states? Because these are the two states which defines the result for any subproblem. In this case, what is a subproblem? The subproblem here for this entire problem would be, let's say the event number was equals to 1 and the k value was 1. This means that if you have all the events from index 1 to index 2, that means if you had 2 3 8 and if you had 3 4 3, if you had this as the event array, and if the k value was equals to 1, then what would be the maximum profit? So let's say the maximum profit that you get is x. Then that means if you had these two items from the array, that means these two events, and the maximum attainable set of events was 1, then the maximum profit that you can make is x. That's the meaning of it. Okay, so if you try to create all possible combinations of these subproblems, then you can imagine that you can take the event number on x-axis, k value on the y-axis, and then it will create all possible set of problems. So let's take it. Event number on the x-axis, how many events are there? 0 1 2 3 events are there. And the k value on the y-axis, so how many k states can be there? Now the k states can be k plus 1, because k equals to 0 is also an state where you cannot include anything, right? So here, since the k value is 2, I will have 3 states in the k side, and the events are 3, so I will have 3 states on the event side. Now this is the entire subproblem, and if I write here x, this means that if I am looking at this event number 1 while moving from left to right, and if my k value is equals to 2, then what will be the maximum profit? Maximum profit will be x. Okay, so this table here will show you all possible combination of the subproblems, and I will call it, let's say, memoization, and the dimension of it will be equals to n by k plus 1, and I will preset all the values to -1. Why -1? Because you will find that all the profit values are positive, all the value at I are positive, right? So by adding positive numbers, you are going to get only positive numbers. So if I fill all these values with -1, this means that they have not been computed. Okay, and if they have not been computed, I will apply the recursion and try to compute that value. But if a value is non-negative, it means that that subproblem was seen already, and so I need not calculate it again, and that is why I will take the benefit of repeating subproblems, right? So I hope you now understand how this recursion code is related to the dynamic programming, because there will be repeating subproblems whenever you are at an event and the k value is the same, then it is repeating and it can happen multiple times. So the number of unique subproblems in this case is nk, and each of the subproblem will only be solved once, and solving a subproblem requires only one time. So the time complexity is going to be order of nk, but there is a previous sorting step as well, so that will be in the pre-computation n log n time, where n is the number of events. So this is going to be the time complexity, and the space complexity is going to be order of nk due to the table. Okay, so the space complexity is order of nk, time complexity is n log n plus nk. I hope it is clear. Now in this case, you would have actually tried out one more optimization where we can create a next array. Let me show you. So you can create a next array, or the next event array, you can say, where the next event will tell you about what will be the next event of the 0. How will you find it out? Instead of iterating through each of the event one by one, what you can do is, once you know that the event 0 is ending at 2, then you know that the next event is going to be the earliest possible event which is greater than 2. So either you do it by iteration and try to find it where is the next start point which is greater than 2, or you apply the binary search, particularly the upper bound binary search. Now what is an upper bound? In case if you have the array values 1 2 2 4, 4, 5. If these are the indices 0, 1, 2, 3, 4, 5, and if you apply upper bound on 2, then this will return you index 3, which is saying that the first occurrence of the value greater than 2 is at index 3. This is the use case of upper bound. So you can try to implement it yourself if you are doing it the first time, or you can use the library function. So if you do it, then I can pre-compute all the next events for each of the event, and I can make an array out of it. Therefore, if you pre-compute the next event for the given events array, then you will find that for this index 0, the next event is going to be 2. Okay, because this is the earliest possible index which is non-overlapping. For this one, there is no earliest possible index on the right because 2 is overlapping. So this will be 3, which is out of bound, and for 2 as well, it will be 3. So now if you look at the recursion tree diagram from 0, if you have included it, then I would not have made a call to 1, but I would have made a direct call to 2, because I can just look at the next event array and say that if you have included the 0th index item, then its next index is going to be 2, and that is how I can optimize this recursion tree diagram as well. So I hope the pre-computation step is also clear, right? And if you are clear with this, let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, I have taken the memoization table, the next event pre-computed array, and the value n, which will say the number of events. This is the main function max value, where the events are given with the k value, finding the event size and sorting them based on the start point. If two start points are same, the end points, smaller one would be taken first. Then the memoization table will be pre-assigned with value -1, and the next event array will be computed now. So as I had mentioned, we will be using upper bound for it. That means if an event is going from 1 to 3, then the next event must be as early as possible, but must be greater than 3. Now we will be making the recursion call to attend event. If you look here, we are passing the events, the current position we are looking at, we are parsing from left to right, and the k value. If k value becomes 0, that means we cannot include any more events, so it's useless to see more events, just return 0. Or if we have gone out of bounds, then also you return 0. If the current subproblem is pre-computed, then result the value of it. You do not need to recompute, or otherwise we will be computing it. So if you are at an event I, then if you choose to not select this, that means you want to skip this event, then you will go to event at i+1, as I had already mentioned. Or if you want to include this, then you will be going to the next event. So look at the pre-computed next event for the given event at position, find out the next index, and you will be trying to attend the event. So you will be going to e at next, okay, and get the profit out of it. You will be adding the profit for attending the ith event as well. And finally, we need to return the maximum of both the exclude and include cases, and we need to store it in the memoization table before returning. So this is the entire solution, and I hope it is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.